So in section 3.3, we are exploring Cramer's rule and volume and how it relates to the determinant of an invertible matrix. So looking at Cramer's rule first, Cramer's rule is studying how the solution of the non-homogeneous equation, matrix A times vector x equals vector b, is affected by changes to the entries of vector b. So here's the rule itself. We want to start by letting matrix A be an n by n invertible matrix. Then for every vector b in Rn, we let matrix A sub I of vector b be the matrix attained by replacing column I with vector b. So if we have some n by n matrix A defined by column vectors A sub 1, A sub 2, all the way up to A sub, well, somewhere in here we have column vector A sub I, and this goes all the way up to vector A sub n. The matrix A sub I of vector b is the same, has the same columns, except A sub I is now replaced with vector b. So then Cramer's rule tells us that for every vector b in Rn, the unique solution of the homogeneous equation has entries given by the following form. So we have that each entry has the form x sub I, which is defined by the determinant, is defined by the ratio of the determinant of matrix A sub I of vector b all over the determinant of matrix A, and this is where I is in integer 1 all the way up to n. So this formula here is Cramer's rule to determine the entries of the matrix. And the only thing I want you to note before you proceed is that this formula, Cramer's rule, is an ineffective or inefficient method for hand calculations. This is only going to be useful to us who have no use of a calculator on quizzes or tests if we're working with a 2x2 matrix, maybe a 3x3 matrix, but as we'll see shortly, these calculations can be intensive. So let's explore.